Hello and welcome to lesson 214, day 1. The focus of this lesson is going to be completing the square again. We've been talking about this for about the last week and a half, so we just need to see a few more examples and make sure that we are ready to do this on the quiz this week. All right, so we're going to learn how to go from standard form to graphing form using the completing the square technique. We're also going to learn how to identify the vertex once we're in graphing form. We want to be able to describe the transformations given in an equation. All right, so if I give you an equation in graphing form, can you tell me what transformations took place? And then lastly, we want to be able to write the equation of a parabola given a graph. All right, so going from graph to equation. All right, so let's look at completing the square. So it says complete the square and write in graphing form. We have a parabola given to us in standard form, right? As we talked about this yesterday, this is where the three things are being added together. So this is standard form. And the way that we complete the square is we start by taking the x squared term and putting it in the upper left-hand box. We then take the middle term and we cut it in half, right? So if I take 4x and I cut it in half, I'm going to get 2x. So I'll put 2x and 2x in the first diagonal. Then I'm going to start working on my outside dimensions here, right? So if I focus on this upper left-hand box, I need to multiply two numbers to get x squared. So the only way that's going to happen is if I do x and x. Now x times whatever number goes here has to give me 2x, so this has to be a 2. And x times whatever number goes here also has to give me a 2x, so that also has to be 2. And I've said this before, but this is why we call it completing the square, because while this might be a rectangle, notice that the height and the base are the same length, which means it is a square, right? That's why they call it completing the square. So to go ahead and finish this off, I'm going to do 2 times 2, which gives me a 4 in the bottom right-hand corner, and then I'm going to start writing my equation. So I'm going to say y equals, and then I do x plus 2 times x plus 2, and I can simplify that a little bit by combining them and using an exponent. So anything times itself is the equivalent of squaring, so I can say x plus 2 squared. Now remember, I have a 4, but I needed a 9. Okay, so in my original equation, that number that should go in the bottom right-hand box should be a 9, but because I completed the square, I got a 4. All right, so I have to figure out how do I go from a 4 to a 9. So to go from 4 to 9, I would have to add 5. 4 plus 5 gives me a 9. So I need to add 5 on the end of my equation. Okay, so there we are in graphing form, and if you forget what graphing form looks like, I put it down here at the bottom for you. So remember, it looks like this with the parentheses squared, and you have plus some number on the end. There's usually an a value here, but for ours we have a 1, so we don't write it in. Okay, now once we're in graphing form, we want to identify the vertex. Remember, the vertex is that minimum or maximum on our parabola. So it's going to be a point, right? And we can find that point by looking at the horizontal and the vertical translation of our parabola. So notice that we have a plus 2 here. That means our vertex moved to the left 2. So it'll be located at negative 2. And we have a plus 5, which means our parabola moved up 5. So it'll have a y-coordinate of positive 5. So the vertex of this parabola, without even looking at the graph, without looking at the table, is negative 2, 5. Okay, let's try one more. All right, so same process. I'm going to put the x squared in the upper left-hand box. The 5x gets chopped in half, so we'll have 2.5x in that first diagonal. And then I'll start on my outside dimensions. So we'll have x and x. And then over here we'll have 2.5, right? Because x times 2.5 is 2.5x. And we'll get the same thing down here. Right? So x times 2.5 gives me 2.5x. Now to get my bottom right-hand box here, I need to multiply 2.5 by 2.5. And I get 6.25. It's okay to get decimals when you complete the square. And then I'm going to write my equation. So y equals, I'm going to have in parentheses x plus 2.5 squared. And remember, I'm at a 6.25 when I complete the square, but I need it to be a 2. So I'm going to have to subtract. I'm going to have to go from 6.25 down to 2, and to do that I need to subtract 4.25. So there's my finished equation in its graphing form, and now I'm going to identify the vertex. A plus 2.5 inside of the parentheses indicates a left horizontal shift, 2.5 units, so we're going to go to negative 2.5 for the x-coordinate, and a minus 4.25 on the end here indicates that it's been shifted down, so it'll be at negative 4.25. Right, so this is my x and y coordinate for the vertex. If you were to graph this thing in your calculator, this is where you would find the vertex. Okay, let's continue on. All right, so describing transformations from the equation. So if I gave you an equation, could you list the different transformations that occurred on this parabola just by looking at the equation? All right, so remember, when we look at this graphing form, we look at the a value to determine either a vertical stretch or a vertical compression. We can also look for a negative to be in front to determine if there was a reflection. So when I look at this, I see a negative right here, so I know that it has been reflected over the x-axis. The 2 tells me it's been vertically stretched. So remember, if it's a number bigger than 1, it has been stretched. If it's a number in between 0 and 1, it's been compressed. Okay. The minus 5 inside of the parentheses, that is our h value and indicates our horizontal shift. Since it was a minus 5, it would be shifted right 5. So remember, it goes opposite of what you think it would based on that sign. And then this plus 6 on the end, that is our k value. So I can tell that this has been shifted up 6 units. Now the way that this kind of problem is formatted on MyOpenMath is they will give you several different options to choose from. You want to make sure that you would select these 4 options. You would have to check all 4 to get them correct and none others. All right, so let's try it again. This time f of x equals 3x squared plus 4. Now this one doesn't seem like it is in graphing form, but we could rewrite this thing. And let me show you how. All right, so I could rewrite it like this. And it's a little trick, right? Because x minus 0 is the same thing as just x, like what we have up here. Right, so I put the parentheses around it and put a minus 0 on it, so it looks a little bit closer to what we see here in the graphing form. And once we're in that graphing form, it's easy to identify a, h, and k. And I can go through and list my transformations. Now there is no negative here, so it was not reflected. So I'm going to just go right to the vertical stretch, right? Because 3 is bigger than 1, so it has been vertically stretched by a factor of 3. The minus 0 indicates that it was shifted to the right or to the left 0 units, but you can just say it was not horizontally shifted at all because it is a 0. So I wouldn't even write that down. And then here, for the k value, the plus 4 indicates that it was shifted up 4 units. So really only 2 things were done. It was vertically stretched and shifted up 4 units. All right, let's keep going. All right, in these following 2 problems, we did one of these yesterday, and this is where we go from the graph to an equation just by looking at the graph. No solving, no anything like that, just using the transformations that we see in the graph to write an equation. Okay, so I'm going to start just by finding my a value, and if you read the directions for this one, it says that you can assume the stretch factor is 1 or negative 1, right? So it hasn't been stretched or compressed at all, right? But the parabola is opening downwards, so it would indicate that we have a negative out front of the parenthesis. So I'm just going to start with that, negative parenthesis, which is the same thing as saying negative 1, right? So we selected this one because it opened downward. And then I'm going to go x minus. Right, and the h value, we can determine the h value by looking at how far to the left or to the right the vertex has moved, right? So I'm focusing on this point and using it to determine how far left or right and how far up or down it has moved. Because if it wasn't moved at all, that point would be starting here. Okay, so If I look from here to here, that means I moved to the left 3. Right, so we moved to the left 3. So if I want to move left 3, I need a plus 3 in my equation. And then it went up 2. Right, so that means I need a plus 2 on the end. All right, and this would be my final equation for this parabola. So I use the vertex to locate the horizontal and the vertical movement, right? Because it would normally start at 0, 0. So wherever it's at, I just look at how far left or right it moved and how far up or down it moved. That gives me these two numbers here. Then I just identify whether or not it opened upward or downward to determine if I need a negative out front of the parentheses. Let's do one more. Okay. So again, I would start by writing my blueprint, right? That's my graphing form. And then I'm going to determine, well, it opens upwards, right? So this is going to end up being a positive 1. So I'm just going to say y equals, and if you really want, you can put a 1 in front of the parentheses. It's not going to be counted wrong if you do, but it is not necessary to put that 1 there. And I'm going to leave a positive because the parabola opens upwards here. Okay, now remember, the vertex of a quadratic usually starts at 0, 0, but this one has obviously been moved. It has been moved to the right 2. So to move right 2, I need an x minus 2. And then it has moved down 3 units. So to move down 3, I need a minus 3 on the end. Another common mistake that I saw in the quiz you might want to pay attention to, a lot of you guys forgot your exponent on the parentheses. Without that exponent being a 2, you would not get a parabola on the graph. So it's important that you include that. All right, guys, that's it for today. Good luck on the practice problems. Let me know if you have questions in the Zoom chat.